That is the nature of renewables, is that they are variably available, and we have to take advantage of that, not fight against it, and not constantly wish we were in the fossil fuel age.
Hello, and welcome to Environment Variables, brought to you by the Green Software Foundation. In each episode, we discuss the latest news and events surrounding green software. On our show, you can expect candid conversations with top experts in their field who have a passion for how to reduce the greenhouse gas emissions of software. I'm your host, Chris Adams. Hello, and welcome to the Green Software Foundation podcast, where we bring you the latest news and updates from the world of sustainable software development. I'm your host, Chris Adams. In this episode, we welcome back the authors of the book, Building Green Software, Anne Currie, Sarah Bergman, and Sarah Hsu for an episode of This Week in Green Software, our roundup of what's happening and hot at the intersection of sustainability and software engineering. So, Anne, Sarah, I know that you've been on the podcast before, but I wanted to just provide a bit of space for people who are new to this to let you introduce yourselves. And is it okay if I give this floor to you before we run through the usual roster?
Yeah, thanks, Chris. So my name is Anne Currie. I am the CEO of a training company, Strategically Green, and I have been in the tech industry for pretty much 30 years now. And I am one of the co-chairs of the Green Software Foundation community group.
Cool, thank you, Anne. All right, Sarah, is it okay if I hand over the floor to you next?
Sure. Thanks for having me back. I always enjoy being on the podcast. So my name is Sara Bergman. I am a senior software engineer at Microsoft, where I work with the Microsoft 365 products, which is very fun and exciting. I'm also one of the co-authors of the book, Building Green Software. And other things that are new in my life is I'm recently back at work after maternity leave. So I'm still figuring it out. You know, what is life now?
Well, welcome back and congratulations on, the new instances of Sarah, I suppose. Yeah. Okay, and moving on to other Sarah. Sarah Hsu, if I give space to you to introduce yourself.
Hi, everyone. It's nice to be back. So my name is Sarah Hsu. I am an SRE working for a financial institution. I'm also a project lead for the Green Software course for the GSF. And similar to Anne and Sara, we recently just published a book by O'Reilly called Building Green Software. Very excited to be back.
Cool. Nice to see you again. And Sarah Hsu, we met in person for the first time when you were in Berlin delivering a keynote for, was it CommundaCon, the conference there?
Yes, a process orchestration conference, which is exactly what we need, right? Because their motto is automation. And automation is the foundation of modern software systems. So
thank you for that, Sarah. I was also pleased for us to both realize that we had arms and legs and were more than just a YouTube square, basically, or a square in a Zoom call. So yes, that was lovely as well. Okay, for folks, if you've never been listening to this podcast before, my name is Chris Adams. I am the executive director of the Green Web Foundation. It's a Dutch nonprofit focused on reaching a fossil-free internet by 2030. I also work as one of the policy chairs of the Green Software Foundation Policy Working Group as well. And before we dive into some of the stories, that's the format of this show, we'll be sharing links to the show notes and all the stories that we do discuss. So they'll be on GitHub and Markdown. What else for you to look through? All right. So the format we normally do is do a roundup of news stories. But you three, because I have the pleasure of speaking to people who've written a book about green software, we figured we'd make it a little bit more interesting for listeners and touch on some of the topics in the book. So we've got a bit of a kind of nice way in to cover some of that content. Does that sound okay to you folks?
Great.
All right then. So the first story that we have is actually about a new project called SpinCube. So this is high proficient serverless on Kubernetes powered by WebAssembly. Now, a few podcasts ago before, we did a whole story all about WASM, WebAssembly, and why it's an interesting piece of software. But previously back then, it was only available on Nomad, which is a similar scheduling tool, but not the same as Kubernetes. And this story, as I understand it, is basically the idea of providing some of these kinds of tools for Kubernetes, the most popular scheduling tool for this. This basically means that if you thought that was a cool idea, you've got access to it yourselves. And Anne, I think I might hand over to you for this because this really touches on some of the things you spoke about in your book about operational efficiency versus coding efficiency. Maybe I'll hand over to you here.
It really does. So WASM is something that I find absolutely fascinating. And both, as you say, both from at the moment, the operational efficiency perspective, because they're really focused on how you can bin pack as much work onto each machine as possible. So you can reach that magic 50% utilization number and then get even higher, which is very hard to do without a tool to help you, very hard to do. But beyond that, what also is that they have ambitions even further, which is that they want to start actually optimizing the code that you write in WebAssembly as well, so that under your feet, it will become more efficient. And we all know that writing efficient code is really, really hard. There's a huge impact on developer productivity. And we covered this quite a lot in the operational efficiency and the code efficiency chapters of our book. And one of the senior engineers, Danielle Lancashire at Fermion, who's behind all this WASM, one of the groups behind all this movement in WASM, came and talked for me at a conference in London a few months ago. And she was actually talking about code efficiency, the code efficiency improvements that come from WASM. Now, they're a bit down the road. The moment they're focusing on operational efficiency, but I really like to see a platform with a vision for, because in the end, we're all going to have to run on much, much less power at times when the sun isn't shining and the wind isn't blowing. That is the nature of renewables, is that they are variably available. And we have to take advantage of that, not fight against it and not constantly wish we were in the fossil fuel age. And so I really like to see a platform which is thinking about operational efficiency now and also thinking about code efficiency down the road. So I like WASM from that perspective. I think they're doing a lot of nice work.
Yeah, we have some nods here. I just realized when I spoke about this story, I dived straight in without really explaining why some people find this actually exciting in the first place. So when we spoke about things like, say, serverless, and as I understand it, one of the key things behind this tool is it's like a very fast version of a serverless platform that spins up and down quite quickly. So we've had previous generations where you might need to have a bit of a wait before a piece of software can start running before you can really use it. And this is like one of the key things that WASM has made available. And that allows for, like you said, time. It basically means that there's less wasted time, but it also opens the door for newer, more efficient platforms like this. Okay, before we move on to the next story, Sara, is there anything that you want to add to this?
Actually, before we move on, I'm going to just hark back to something that Sarah said just before this, which is that the benefits of modern ops and automation is that a big part of modern automation is the ability to spin up quickly. Because things like replacing just having stuff sat around waiting and for you to fail over to with autoscaling, which is vastly more operationally efficient, relies on things being able to spin up fast. If you can't have fast instantiation, you can't have a lot of these modern automation, this modern progress in automation. So yeah, it is a really good thing.
Also, I think one thing that has been said before and can always be said again is the benefit of these sort of platform that makes it easier for people, because people want to be green, but sometimes it's a lot of work, and anything that can make it less work to be greener is a great thing and should be celebrated. And on the ops side of things, not every software developer or software person is like highly interested in that. There are some people who love it and like go all in, and there's some who like, I just want to write my code and like deploy it in some way to my users. So therefore, things like this is so important to help bridge that gap in a green way.
Yeah, I 100% agree. Like software engineers, we're inherently lazy people, right? Like not speaking for you guys, I'm not a security expert, but I know how important a secure application is, right? I'm waiting for this tooling framework and best practice from the security people. So I think that's the gap we're really trying to fill, that how do we make everyone else have that ability to be green at their fingertip without having all the knowledge of like being really green. And like, yeah, I feel like we can talk about operation efficiency to tell tomorrow.
So the cows come home.
Yeah, because it really is the lowest hanging fruit, and people don't realize how many things we're already doing or have like knock-on green benefits, like exactly what Anne said about reliability and resiliency. yeah, they all like come down to like automation and how do you utilize automation, right? Anyway, I think we should stop. We can always come back to it. Let's get through all the other stuff and then we come back to talk about green ops.
Okay, all right. Duly noted. All right, so we spoke a little bit about operational efficiency, which is the running of servers. Spoke a bit about coding efficiency, which is what a lot of people might reach for first, or people won't typically think about. But there's other ways you might talk about this. So let's move to the next story. Sarah, I might actually ask you about this one. So this one is a story from Grist magazine, which basically it covers the staggering quantities of like transition metals that we're currently throwing out when we could be mining them. And while we'll share a link to this in the show notes, one of the key things that the four of us can see right now is a chart showing some of the minerals that we hear associated with a transition away from fossil fuels to greener forms of power. There was a report by the UN called the Global E-Waste Monitor, and they've shared some of these stats for the first time. And one of the key things is basically that we are throwing out something in the region of 62 million tons of electronics. And when you look at the actual mineral content of that, in some ways, it's actually comparable to the demand for new kinds of metals that we have. So the charts that we'll link to here are things like, say, copper. It's not that, it's quite similar to each other. Some things like cobalt or neodymium. These are, we're basically looking at the amount of minerals that could be circular. Some cases are not the same. So that things like lithium, for example, there's still a lot of demand and there's not nearly enough that's in circulation. But this feels like this provides an interesting flip side to the whole discussion around what we do with our stuff. And I think the term that I saw in the book, which was hardware efficiency. So I kind of wanted to see what you folks thought about this, in particular, Sarah, because this is one thing we spoke about in a previous podcast. Like, this feels like there's more than just hold on to your kit, for example. There's maybe a chance to talk about things in a more circular fashion.
Absolutely. And I think the key word there is circularity. E-waste is the fastest growing waste stream in the world, which is saying a lot. And it is growing for several reasons. Like, we consume more, we have more devices. Like, more devices are smart devices. My kitchen fan has an app. I don't know why it needs an app, but there are an increasing amount of what can be classified as not what can be classified, but what is electronic. I see the same with like toys and things. So that's one thing. And also we crave newer and newer things, and things have shorter and shorter life cycles, or the use phase is short and shorter. So it is fast growing. And when it was not the case that it was so fast growing, we could maybe afford to mine everything. But now, when the consumption is so high and the throwout rate is so high, we really need to start thinking in a circular way, because in the end, there is only so much metal in the ground, and our Earth is finite. It's not something that grows back, at least not very quickly. So having this thinking, I think it needs to be a game changer. And I know several countries have adopted what's called the right to repair, which is basically that you can repair. Yeah, it's a big thing in Europe. India has a similar legislation. New York has a similar legislation. And that's really good. And that's about what you said, holding on to your kit longer. But that's really only one side of it. I think the right to recycle should be equally hotly debated, perhaps even more hotly debated, because the hardware industry has been forced to make hardware kind of hard to recycle, because we are demanding better, yet smaller devices, or bigger screens, but thinner, lighter hardware. And that's really complicated to produce, and it makes it really hard to recycle. Also, in this article that you linked, let me find the number, but what they said, the percentage of ethically recycled waste was also staggeringly low. It's like a business as usual case was only 20%. You're all going to have to go to the show notes and read the article for yourself to find the percentage. What I'm meaning to say is that this is incredibly important, and something that is an additional dimension to the conversation beyond holding on to your hardware. It's also the reuse and recycle part of the story.
It's a sales feature as well. Recycling and is a sales feature. I just bought a new phone. It was an old Pixel, a 7A, because my previous one had run out of security patches, the classic way that you have to throw away a working piece of kit. So I was quite annoyed because I was having to throw away a perfectly working piece of kit. So I bought myself a new 7A. But the 7A sent me all the stuff to send my old phone back. And I got 25% off. And I thought, well, actually, that was pretty good. I actually felt quite good about that in the end. I thought, well, it's going to be recycled. I got 25% off, hooray.
Yeah.
It felt like a feature that they were offering me.
Well, this touches one of the key ideas that if you're moving away from linear economy, once you've dug these minerals up once, one of the ideas is that once they're in the kind of sphere that we're in, right? You don't need to have, it's not they're going into the atmosphere like, say, fossil fuels, for example. You can have these things circular. Now, this is one thing that we don't have quite the policy support for yet, but this is one thing that we could definitely be seeing more of in future. And this feels like the direction we might be heading towards if things work out, basically.
Yeah, I also think it's an age-old thing, right? We should find the thing that fits your purpose. It's similar to say we want to find the VM instance that fits my purpose. I feel like people shouldn't want the latest and the greatest. Like my laptop is not that great, but I don't do that much on my laptop. So like, I think people also need to start having that mindset like, oh, I don't need like the fastest, like the most cores power laptop just to go on Zoom call, do a little bit coding. And that, yeah, I think that's another bit of the things that also really fit into operational efficiency, where you want to find things that fits your purpose. And I think that applies to hardware as well.
I agree, actually. All right, thank you for that, Sarah. All right, so we're going to move to the next story now. This is a story from Carbon Brief. And Anne, I'm going to hand over for you for this one because this is one thing we discussed before. So this is a story from Carbon Brief who basically mentioned that earlier on last month actually now, the UK's electricity grid operated for a whole hour with just almost no power coming from fossil fuels. Now, this is a record low for the country. And this hopefully is a sign of things to come. So Anne, I know that we discussed this here, but maybe you could touch on like why you found this interesting and what it's kind of telling us as software engineers, perhaps.
Yeah, I mean, obviously, this is an incredibly positive story, and it's actually the direction that almost everyone is going in. If you haven't had a play around with electricitymaps.com to have a look at how green all the grids of the world are, it's absolutely fascinating. You'll learn a lot. And if you step back in time, it shows you what the carbon intensity, the average carbon intensity is of every grid in the world that they can get data on, which is a surprisingly large number of grids. You'll see that you can go back in time and step forward, and you'll see everything is becoming greener and greener. The energy transition is happening. It's not just something that will be happening in the future. It is happening, but it won't be easy. I saw an excellent Uruguay is apparently completely 100% green for 8 solid months this year. So but that is because, but the interesting thing on this is that every country does it in a different way, and every country being the green intensity of their grid, it varies over time in different ways. It depends what you're using to generate the power. So places like Uruguay have loads of solar and wind, which is fantastic, but they also have tons and tons of hydro, and the hydro is used to smooth out the times when the wind isn't blowing and the sun isn't shining. In the UK, we don't have so much in the way of stored. So it's great if it's windy and if it's sunny, but mostly in the UK, it's if it's windy. We do an awful lot of offshore wind, rather. Not onshore wind, but offshore wind.
I thought you were going to say we don't do a lot of sun here.
We do not do a lot of sun here. It's not as bad as I've got solar panels, and through the summer, through half the year, that will cover all my household usage. It's oddly much better than you'd think, but nonetheless, in the UK, it's mostly wind. But not so much in the way of storage. So the UK is an absolutely excellent example of we're going to have to get good at using power that's variably available and cheap when it's available, and either demand shift or demand shape, so that we are using the renewable power and using less of the non-renewable stuff. So it is absolutely fascinating. It's a great story. It's a really good move forward, but not all grids are identically green. They all have different ways of doing it and results.
All right, I've got a pop quiz for you then, because you're talking about the fact that the grids change and sometimes they're going to be greener because there's more clean generation on the grid versus other times, right? We know in the UK, for example, there's groups like Octopus Energy who basically will change the cost of your power depending on the time of day. In some cases, you even pay you to use this. And we see this in other parts of the world. When do you reckon we're going to start seeing cloud providers do this in the net? Because we know it happens, and we see this stuff, but none of these signals are passed on to software engineers yet.
No, and every time I'm speaking to somebody from a cloud provider, I ask about it. And normally the people are quite green people and they want it to happen, but I think it'll be a way off. Now, it's interesting. I spoke to somebody who was working for a cloud provider, but was a software engineer who used to be in the insurance industry. And he was saying to me, oh, well, I can totally see it being to the advantage of the cloud providers to start doing dynamic tariffs, time of use tariffs, because then they have another product they can sell. So the people who can't do it, they will sell them insurance with a price cap. And obviously they'll charge a load of money for that. And then that is a product. Now, is that what they're going to do? They'd be quite sensible to do it. It's, the cloud providers are very good at making money, and it won't be cheap. So I would love to see it. I think it's going to be years before it happens.
Okay, so you're thinking 3 years at least for you, Anne, yeah? Okay, any other takers for anything faster?
Yeah, no, I think, working for a cloud provider, I just want to say I don't know. But what I think at least the major cloud providers are fairly open with their use of PPAs, so power purchase agreements, as a way of, meeting the green energy needs, because they have data centers sort of where they need to have data centers, and then use PPAs to handle their scope 2 emissions. And I think because all of them at least are so seemingly tied to those agreements, it is a contradiction between those and billing a customer for actual usage. So I think it could be like a complicated thing for them, is what I suspect. But I also think it's something that customers would really appreciate. So I'm hoping it will be sooner, but no, I'm with Anne.
Okay, years away. And Sarah, you got something to say, it looks like.
Oh, I was just going to say, probably not in the near future, but we just need one person, one cloud provider to do it, and everyone else be like, right, we need to do it too.
Do you know what? I had a conversation from people outside of the big three, the big cloud providers. So in Texas, there's a company called Build AI. They've been doing some work to basically, they'll provide you computing, but at certain peak times, you don't have access to it. And as a result, they're able to have much lower costs for this stuff. So I'll share a link to that. And there's a company called Soluna, also in Texas as well. And what they do is they speak to generators, people who run like clean energy. And they'll basically say, we will give you a floor price under which you will never, we'll always give you something like that. And using that, they are able to provide these kind of services. So we are seeing this start to develop, just not with the big providers. And I guess the next question will be, at what point do these new providers get bought by the big providers to protect the margins? Because that might be the logical thing to do if you have these kind of funds. All right, let's move on from that, because that was we spent a bunch of time talking about carbon awareness, and there's a few other stories that we have up here.
But carbon awareness is the most important thing.
It's definitely...
And operational efficiency.
All right. Okay. So let's move to the next story then. So we had another story here. It's actually probably the nerdiest story we have here. This one is actually a link to an issue in the OpenTelemetry repository. Basically, there is a standard called OpenTelemetry, which is designed to make it easy to understand what I guess it's to make infrastructure observable. And Sarah, I might need some help from you on why observability is important. But this one is basically put forward by, I think, one of the people who's inside the Green Software Foundation to start agreeing some sustainability metrics to expose in all the kind of tooling that we currently do have. This was really interesting because this feels like, this is something that I saw discussed in the book, but also for people who are not familiar with OpenTelemetry, or even observability in general, is anyone who might want to go enlighten us, or at least give us some pointers about why this might be interesting from a green software perspective? Sarah, I might hand over to you because you wrote part of this chapter for the book, I believe.
Yes, so I guess observability was born out of necessity because things are so complicated now. Microservices is made out of our world, and sometimes one request have to travel like the entirety of a street of like 100 houses before they actually reach a part of their journey. And it's really impossible to figure out what and where things have gone wrong, right? Metrics is for when you know something is going to go wrong, and then you set up a metric to monitor that. But then in this unknown world, it's really hard to figure out who is going to break. For example, like, I forgot that guy's name, but someone from Honeycomb. You guys know how much I love Honeycomb. He gave a really good example. Like if you're like an iOS developer and you support like 10 different phones in 10 different countries, and suddenly one version of the phone in this country is going to break, how do you know to monitor that using metric? So I think that's a really good example, like why we need observability. And observability borrow this thinking from control theory, which is like we are trying to understand the internal state of a system by just looking at its outputs. And outputs here are like telemetry. And telemetry, you got logging, you got metrics, you got traces. And so basically open telemetry is like a set of framework. It's about the creation and then the management of those telemetry. It's actually not a backend. So it's not like Prometheus, it's not Jaeger, it's not like Grafana Cloud. It's just a convention, which is really good. I remember when we were all in QCon a few years ago, and Daniel from Skyscanner was talking about their OpenTelemetry migration plan or something. They basically went from like 300 different components down to 150 because they use OpenTelemetry as a standard, as an auto collector. And then that's the way, become one-stop shop for all the telemetries. Like you don't need developers sending 3 different telemetries to 3 different backend systems. And then one big thing, everyone's being on call here. One big thing we find difficult is how do I context link everything? Why I need to basically, this logs happen at 1:21 p.m. Right, let me go find the traces. That also happened. But what if time shift, right? And sometimes like something is in a different time zone. So anyway, that's a massive rant about why we need observability. So I know, sorry. It's my job, guys. And then I guess one big thing we talk about in the book is that green software needs to be ready with observability. Like we need to be with it, right? So for example, in this complicated microservices world, we want to be able to know which component, which process is emitting the most carbon, right? And that's where we want to be. And we need OpenTelemetry. We need people like OpenTelemetry to help us get there. So it's like absolutely amazing to see so many people are standing up and then it's like, hey, we should add this like semantic thing.
I'm really excited about seeing this because I've used Honeycomb to understand what was broken about some applications I've been running before. And I was always a little bit wary about saying, well, okay, I'm not sure about, I want to be totally tied to one provider. And this here and we have seen some providers who have started to make some experiments in exposing CO2 figures for this. There's confusingly a company called Sentry that do provide this. And they even propose like a HTTP header for CO2 per request, right? But to see this at a kind of standard level, this feels like it might make it easier for a larger set of providers to come up with, and at least make it easier to kind of see some of this, because I think this is something that came out of the book, was that you need to observe this, but it's often quite difficult to get the underlying numbers from some providers, and this is something that we need some more work with, or we need some progress on, basically.
Yeah, and I guess one big thing about OpenTelemetry is that because it is just a framework and it's vendor neutral. I think sometimes people forget how important staying vendor neutral is. So yeah, I think that's why it's so important that we locked in with OpenTelemetry now, because it is going to be the solutions for this observability space going forward.
Absolutely agree, because I think sometimes when people talk about software, they think of a specific type of software that runs in the public cloud. But that is not the entirety of software that exists out there. There's so much software who runs on different places and nowhere near the cloud. And that software is equally important. So having something that fits more than just the one most popular scenario is incredibly important. And I just want to say that I think this is important because I don't think anyone should get away, quote unquote, from doing sustainability work because, I don't know my number. That should not be an excuse.
No, I totally agree. But even if it's impossible to get your number, there's still so much you can do without the numbers as well.
Sure.
And yeah, it's amazing how people go, I can't get the numbers. Well, just work on your operational efficiency.
Yeah. And like one of the biggest takeaway I gave at CommanderCon in Berlin was that you can think of GreenOps as a really natural evolution of DevOps and FinOps. FinOps is about optimization with money, we basically need to do the same for sustainability. And there are so many things we already can do. And yeah, people should really pat themselves on the back because they didn't realize the transition is going to be much smoother than they thought.
Okay, I'm glad you mentioned FinOps actually, Sarah, because this is talking about OpenTelemetry, some ways to expose some of the figures into this. As I understand it, there is is it Focus, which is the standard that the FinOps groups are pushing for trying to come up with like standardized cloud cost figures? Because as I understand it, there are some people pushing to put some CO2 figures in those as well, so that you'll be able to get some of these ideas from not just billing, but also from operational figures. So, because in some cases, one view will give you a slightly different view than the other, for example. All right, we've got this, and we're just moving to the last of the stories that we have today. One of the largest providers has published their sustainability report. Microsoft published their 2024 environmental sustainability report in the last week or so. And there's a lot in it, actually. So they're one of the large providers, and they have various commitments about getting to net zero by certain times, but there's actually quite an interesting amount of data for the nerds inside this. Sarah, I might hand over to you because I suspect that you've been poring over this in quite a lot of detail, actually.
Thank you. Yeah, I think I love it when this report comes out every year because even though I work for Microsoft, there's no way I can keep up with everything that's happening. Like, it's just too big. So I always learn so much. But I think for me, I'm a measurement geek, in case that wasn't obvious already. So some of the things that I thought was super interesting was firstly that the PUE of the data centers was published. I don't think Microsoft has ever published that number, but they said that this year the design rating of the new data center is 1.12. And I think that's pretty impressive. That's pretty close to 1, which is, the dream where all the energy that goes in goes to actual compute and to no other resources.
I'm glad you mentioned this because I wanted you to actually just, for folks who are not familiar with what PUE means, maybe you could just expand on that a little bit and say why you might even care about that number being high or low, for example.
Yeah, absolutely. So PUE stands for power usage effectiveness. Effectiveness. Yeah, I always mix up the E words. Power usage effectiveness. And I think in the sort of early days of green software, this was a number people spend a lot of time focusing on. It is a number that's higher than 1. So it measures all the power that goes into your data centers and how much goes to actual compute. If all the energy or all the power that goes into your data center goes to meaningful compute operations, your PUE is 1. If only half of what goes into the data center goes to actual useful compute, then your PUE number is 2. So there's been a race to get to 1, so where you waste basically as little power as possible.
And when you say little power, you're talking about like keeping the machine from overheating and melting or stuff like that, right? Like keeping it cool enough?
Yeah, cooling is one thing that consumes a lot of extra power. It's probably the biggest consumption of power, but there are lighting in the data center that also consumes power. So anything that's in there that doesn't contribute to compute go into this rate.
Do servers need to see? I mean, they don't need to be in there. It's not they have I have eyes.
There are people who work there.
Okay, that's fair enough.
Yeah.
Okay, so this is so in this report, they're publishing this information, which has traditionally been a thing that you do not see. All right?
Yeah.
That's one of the key things from this.
Exactly. And I thought that was interesting. And in the sort of early days of green software, this was a number people obsessed a bit about because I think there was this, I don't want to say miscomprehension, but this notion at least that if you just got the PUE to 1, all the problems would be solved. Like magically, everything would be so efficient that we would not have to care about everything else. So people were hyper focused on data center design. And I'm not saying it doesn't matter. Of course it matters. Of course it's important. But it's an area where over time we paid down massive knowledge and spent time on. And in the end, that's only one side, because if whatever compute operations you run are vastly inefficient in themselves, it doesn't matter if all the power going in goes to compute, if the compute is wasteful in its matter. So it is one part of the puzzle, but it is not the most important. But I'm glad to see it getting so close to 1. I think it was very impressive.
Yeah, this is interesting to see this because there's a project called Real-Time Cloud, which is run inside the Green Software Foundation. And one of the key things that people are looking to do is figure out the PUE for all the different regions from all the different cloud providers right now. And they've got carbon intensity figures for each hour of compute. But now they're able to use, because there's this information published at a data center level, or actually a region level, you've got a level of transparency that you don't see from the other two so far. I think Google might be sharing some of this, but we still have a kind of like patchy spreadsheet listing this stuff. What I'll do is I'll share a link to the spreadsheet for this, because this is one of the things that once you have this, that should allow you to start being able to kind of optimize what the carbon intensity and of the compute you're using based on these kinds of figures here. This doesn't touch everything though, and I wanted to just leave the floor open. And Sarah, is there anything that caught your eyes on this? Because there is more to this report than just PUE, for example.
I don't want to be the bearer of bad news, though, although I remember hearing this from Anne, so I'm just the messenger, I'm not the bearer. I remember you, and Anne mentioned that because PUE has got a lot of branding around it at the moment, and people know that is like the sort of like the efficiency factor for a data center. So like people then don't want PUE to go up, even though they need cooling, so they end up using water to do the cooling. So they actually trying to get PUE to as little as possible, closer to 1 as possible, as Sara mentioned. But then they compensate that with using water. And water is another like sources that's just as sacred. Is that how you say that word? Yeah. But anyway, I will let Anne talk about this because I remember I heard this from you.
Yeah, no, as you say, we do fetishize PUE a little bit. It's a measurement and everybody loves to meet it. But the other thing is it's not a carbon aware measurement because it's just a flat number. So it doesn't say, oh, well, actually, this is what we did when the carbon intensity of the grid was high, and this is what we did when the carbon intensity of the grid was low. And actually, we need behavior to change between those two times. So it's nice, it tells us something, but we need to make sure with all things, it's context specific. It doesn't provide a lot of context. And we might need more context. Well, we will need more context in the future.
Okay, so better than nothing. So 2 cheers rather than 3 cheers. So good to see this. But as Sarah mentioned, I believe the technical term is impact transfer. When you go from one factor, like energy, to impacting water, for example. And in some places, you may have data centers sited in regions of water stress or pulling power from like local aquifers and things like that. If that's used for drinking water or agriculture or things like that, that's not really ideal. But there's a bigger discussion about what happens with this water. In some cases, it might be, I think the term is withdrawn and waste and consumed. So you have water that might be taken in and some of it might be discharged, given back. But if it's at a different temperature, that might not be ideal for fish and stuff like that. Or if it's consumed and like just evaporated away, that's not ideal either. So there's a whole bunch here. And maybe this is one of the things we should be hoping to see, or we should be looking to see more of. Is, okay, if we've got data center level PUEs, should we be thinking about water usage effectiveness and other things like that?
I think there's one, I don't know what to call them, but I know they're called Scaleway. And I think you did a thing for them. I think now they have like a landing page where you can see the PUE and their WUE. So I think people are start doing it, but again, like much smaller scale providers instead of like cloud providers.
I'm really glad you mentioned this actually, Sarah. So the thing you're referring to, we'll share a link to this. So Scaleway, they're basically one of the largest cloud providers in France. And they also operate in a number of other countries, but they basically do have these dashboards. But the thing about these dashboards, they were initially created by Facebook in 2014. So there is nothing stopping every data center exposing these numbers from a technical point of view. And like if you're looking at a policy level, what they have there is totally something that could be done. It's something that we could be seeing if people chose to be disclosing some of that. And we might see some of this come out as a result of new laws that may be landing or that have already landed in some countries. For example, Germany has this, but there are more on the horizon actually. Anything to add from there, perhaps? Anne, you're about to just say something here.
I am. So Scaleway, I think it's kind of related to stuff we talked about earlier. I was on this podcast with Scaleway where I learned a lot of stuff about what they were up to. And there's some interesting things that they're doing totally away from PUE and WE reporting. So in Europe, there's a group called the SDIA, which is an acronym I can never remember what it stands for.
Sustainable Digital Infrastructure Alliance. Yes.
Excellent, yeah. And their raison d'etre is to try and get European non-hypercloud data centers to start learning from the American hyperclouds and actually delivering some of those services. And one of the things they're pushing for is actually starting to orchestrate and offer services on your data centers that will provide operational efficiency and code efficiency in the same way that the hyperscalers do, and that generally, your bog standard data centers don't. And that's a really bad thing about bog standard data centers. They don't do this because it's very hard to do. If you can get your data center to provide it, then that makes life much easier. And interesting, on the podcast that I was on with Scaleway, they had one of their engineers on who was working on their serverless offering. So a bit like WASM we were talking about earlier, services that improve operational efficiency and code efficiency provided through your data center. That's what we want. That's where the cloud is good with is potentially green, but only if you adopt them. All these things, if you just lift and shift into the cloud, if you lift and shift into good data centers like Scaleway, you don't get any benefit really, or don't get much benefit. You need to be moving over to efficient services.
Yeah, and I think that was another thing that Microsoft mentioned in the sustainability report, that they are working on several ways to increase resource utilization. And just to mention too, they have these power-aware workload allocations, and they're also smartly allocating CPU cores for internal workloads. Because don't forget, Microsoft is also a software provider, not just a cloud provider. And I thought that was really good that they called out, because sometimes when we say things like this, the hyperscalers are good at this, people question it, is it really worth their time? So I thought it was good to see them calling out specific things that they're doing that can also hopefully inspire others to do the same with their data centers.
So here's one question I have there about this report. So yes, it's very good that you see some transparency here. And yes, there are definitely cases where moving to the cloud can be greater. But we've seen both Microsoft and Google and Amazon, their emissions climb year on year. And this year, we're seeing emissions 30% higher this year than last year, which is not going to make it easy to get to net zero. And this is one of the key things that Microsoft themselves have been talking about, saying, yes, this is a real challenge for us. And a significant chunk of our emissions are in our supply chain. Scope 3 is the largest source. So this is one thing that I think that it feels like when we're talking about this, green software doesn't really have that much to say about right now in terms of the actual creation of data centers. And this is something that I kind of want to open the floor up. How do we actually deal with this fact that things can be more efficient, but still growing in absolute terms? Is this something that we can be doing, or do we need to be having discussions about absolute resource limits, for example, and things like this, or how are we going to get here? I'm going to hand to Anne, and because you've got something, but you're about to say something, I think.
I am always about to say something. I think this is a really the whole thing of the degrowth. People shouldn't be allowed to. We should ban people from doing things. It's a very unpopular argument, and it is why people, are not. Even though everybody now believes in climate change, they don't want to have to give up all the things they want in life. Now, efficiency can often really deliver you the same standard or less. It's not all. Jevons paradox, we all know about Jevons paradox. The Jevons paradox is things become more efficient, and where there's untapped demand, where people really wanted to use them and they couldn't previously because they were too expensive, and now they can. That's a big improvement in life, but it's not a guaranteed lock-in. Everything that you make more efficient doesn't always result in, or overall there being more usage. So we use a lot less electricity to run household appliances now than we were used to. They've become more efficient, and there is still only a certain number of times that you can wash the dishes with the dishwasher, or at some point demand does become.
Yeah, there's an upper limit to how often I want to vacuum my room, for example.
Indeed, yeah. To me, it's quite a low number of times I want to vacuum my room. I'm more worried about things like Bitcoin, where there is no upper limit. So what worries me about things like Bitcoin is there is literally no upper limit to how much you might want to do it. There's no point at which you go, I'm happy now. It's done all the things I wanted it to do. So with those things where there's no upper limit, I think, and they potentially don't have a great deal of benefit for most of society, we might want to go down the China route and start banning them. But for things where eventually an upper limit will be reached and they are providing societal value, I'm minded to let them grow a bit, at least. I don't know what everybody else thinks.
No, you're right. This is a complicated question to deal with. And this is one of the things that's probably bigger than green software that we need to be aware of when we talk about this. Because if we make things more efficient, then we've got to figure out, okay, what's the flip side of this? Like you mentioned with Jevons paradox. We do have an episode with a person called Vlad Kuraoma where we dive deeply into this if you're interested in listening, and we'll share a link to that. There's a number of other things we might want to talk about for this, but what we'll do is we'll share a link to the report so that there's plenty for us to be discussing. All right, I think that takes us to the stories that we do actually have. We're coming up to time. Folks, I want to say thank you so much for kind of coming onto this. If people were curious about these terms that we've been using, like operational efficiency, coding efficiency, things like that, this is what's outlined in the book that you three have been working on. Is that correct?
It is indeed, yes. Building Green Software, the new book from O'Reilly.
And there was one question I was going to ask because we spoke about this a few months ago. So this is currently available right now, and you can get it via O'Reilly. But there was a discussion about this actually going available into the commons eventually. Is it one thing we could just touch on some of that? Because this is a really cool thing about this that I was really excited to hear about when you first shared this with me, Anne.
Oh, yeah, it's like, I feel terrible about this because we just haven't had time to do it because we're crazily busy. We've got to take the code, but we do have a license. We negotiate. O'Reilly very kindly allowed us to make it available under the O'Reilly Creative Commons license, which is a kind of read-only license, but totally that's still absolutely fine. That's great. And so we just need to do it, but we haven't got around to doing it yet because we have to do some tidying up and actually publish the thing. But it will at some point be available under a Creative Commons license.
Cool. All right. Brilliant. Well, thank you for that, Anne. Well, folks, this takes us to time. If people do want to find out about if they're interested in what you have to say or what you've been looking at, folks, are there any, maybe just do a quick whip round of where people should be looking? And if I hand it over to you first, then to the Saras, and if someone has listen to you and they want to find out more about what you're up to, is there a website you direct people to or a network or anything?
Oh, if you want to find out more about me, then LinkedIn is where I tend to hang out these days, and I'm very happy to chat to people and answer questions. Or our website, strategically.green, will give us an idea. And I do an awful lot of public training as well, so you can always sign up for that.
Brilliant. Thank you for that, Anne. And I'm going to go for Sara with an H, if that's okay. So where should people, if they want to learn about your things or maybe hear about your talk, where should they be looking?
Similarly, LinkedIn. I call LinkedIn the grown-up version of Instagram.
Yeah.
But yeah, LinkedIn. And yeah, I do a fair bit of public speaking. So if you're ever catch us or catch one of us, don't forget to come get the book signed. And because it's such fun, you can get to collect all 3 signatures. Because we are never in the same place once.
We're never in the same place.
We're in the same place.
Okay, Sara, and over to you. If people want to find out some of the work you're working on or things, where would you direct people's attention to?
Yeah, I'm also on the Grown Up Instagram, aka LinkedIn. But follow me. Don't send me a friend request because I'm terrible, or what's it called? A contact request, maybe, because I've not been good at accepting or rejecting people. So now it's an uncomfortable list and I just ignore it. And it's a red flag with me. So yeah, you can follow me and that's the best way probably. And then, yeah, I'm speaking at NDC Oslo in June. So if you have the book, come and get it signed. It would be lovely to meet folks. I also have a few copies that I can hand out if anyone catches me there.
Oh, exciting. Thank you for sharing that little one. All right, then. Well, folks, it sounds like, I guess we'll see if people want to follow what you're up to. Millennial Twitter, LinkedIn is the place to go to. All right. What we'll do, if you have any of this interesting, folks, we are going to, and if you're listening to this for the first time, we'll be sharing the show notes with all the links to the projects that we've mentioned here, along with some of the other episodes where we touch on some of the things like Jevons paradox, or some of the finer points of serverless. All right, folks, this has been fun. Thank you so much for giving us the time. And yeah, have a lovely day, folks. See you around, all right?
Cheerio, everybody. Bye-bye.
Bye, guys. Lovely seeing you.
Thank you. Bye.
Hey, everyone. Thanks for listening. Just a reminder to follow Environment Variables on Apple Podcasts, Spotify, Google Podcasts, or wherever you get your podcasts. And please do leave a rating and review if you like what we're doing. It helps other people discover the show. And of course, we'd love to have more listeners. To find out more about the Green Software Foundation, please visit greensoftware.foundation. That's greensoftware.foundation in any browser. Thanks again, and see you in the next episode.